The amount of availability you can achieve and how you achieve it depend on your design. In this scenario, we're going to look at how you can achieve 99.9% availability for a traditional web application. Traditional applications are your Windows or Linux apps that traditionally run in a data center. On AWS, you run these applications on Windows or Linux EC2 instances. If you can lift and shift an application from your data center to AWS without changing the application's code, then it's a traditional application. Suppose you have a traditional web application backed by a SQL database. The Apache web server and PHP provide the web front end, MySQL provides the database, and everything runs on Linux. And the application has an availability requirement of 99.9% per year, 3 nines. That means you can tolerate up to 8 hours, 45 minutes of downtime per year. This application has been running in a data center for many years, and you now want to lift and shift it to AWS while maintaining that 99.9% availability. How can you do this? Well, it depends on the architecture of the application itself. So to answer this question, we need to know some details about the application. So let's take a hypothetical video processing app. Users go to a website, they upload a video, specify what sorts of processing they want done. Maybe they want to resize it or make it black and white or make it look like a cartoon. You get the idea. The application processes the video, and then when it's done, it gives the user a link to download the processed video. On the front end, there's a web interface that runs on an EC2 instance. On the back end, the application persistently stores data in a SQL database, and that data might include a link to the source and the processed video, what specific processing settings the user chose, and so on. The important point is that the application depends on the database in order to function. If that SQL database goes down, the entire application fails. Likewise, if the web front end goes down, the application also fails. Both components have to be working for the application as a whole to work. Thus, the architecture is going to look like this. This is what we need to achieve 3 nines availability. And in a moment, I'm going to explain how I figured that. But first, let's talk through all of the components here. This is a traditional Linux application, and we're going to run it on 4 EC2 instances. The application depends on a SQL database, so we're going to need a couple of SQL servers as well. This is called a 2-tier application. The web tier contains the web server that the user is going to connect to, as well as the application logic that performs video processing. The data tier, of course, contains the database. Also, we have an elastic load balancer, or ELB, to distribute traffic to the EC2 instances. Finally, because multiple EC2 instances are all running the same application, all of them need access to the same web assets and video files. Storing the processed videos locally on each instance won't work because if an instance crashes or gets terminated, all of the videos on it will be lost. We can use Amazon's Elastic File System, or EFS, to create a shared network file system volume, an NFS volume, that all the EC2 instances share. To reiterate, this architecture meets our availability requirement of 99.9%. But how do I know that? Well, AWS publishes the availabilities of its services in the Service Level Agreement, or SLA, for each service. The SLA for the EC2 service says that a given EC2 instance will have 90% availability. Yes, you heard me right, 90, 9-0. And if that sounds low, it's because it is. In fact, it's very low. Now, remember that reliability is the ability of an application to avoid and recover from failures. We know that any given EC2 instance could be down for as much as 10% of the year, and we cannot change that. That is just not under our control. But we have 4 redundant EC2 instances. So to figure the total availability for the instances, all you have to do is multiply the failure rates together and subtract them from 100. So in this case, 10% times 10% times 10% times 10% is 0.01%. Now, 100% minus 0.01% is, yes, 99.99% availability, which again is just under 1 hour of downtime per year. So this is better than just 3 nines, right? But there's something else we need to consider. Simply adding redundant instances is not enough to increase availability. We have to ensure that if one EC2 instance fails, the other instances will pick up the slack. We don't want the failure of one instance to cause the entire application to fail. This is where the Elastic Load Balancer, or ELB, comes in. The ELB will distribute traffic to the instances while continually monitoring them. If one instance goes down, the ELB will stop sending traffic to it. This is the same way that traditional load balancers work, but an ELB is elastic, as the name suggests, so it scales automatically to accommodate traffic spikes. This means that one ELB is all you need. Now, AWS puts the availability of an elastic load balancer at 4 nines, 99.99%. In this case, the ELB becomes what is called a hard dependency for the application. If the ELB goes down, then our application becomes unavailable. So we need to factor in the ELB's availability into the equation. To do that, we multiply the availability we just calculated for the EC2 instances, again 99.99%, by the availability of the ELB, also 4 nines, and that gives us 99.98%. However, there are some more details we haven't yet considered. To store the videos and web assets, we'll use an elastic file system or EFS volume. The availability of EFS is 99.99%, 4 nines again. The EFS volume is also another hard dependency, meaning that if it goes down, our application becomes unavailable. Thus, our application's availability is determined not only by the availability of the instances, but also the availability of the elastic file system. To factor this hard dependency into our calculation, we need to multiply the availability we came up with a moment ago, 99.98%, by the availability of EFS, 99.99%, and that gives us 99.97%, right around 3 hours of downtime per year. So, not bad. Now, you might be thinking, hold up a minute. Do we have to use EFS? Could we use S3, the simple storage service, instead? And the answer is that you could, but remember, this is a traditional application that is designed to store data on a standard file system. It is not designed to use S3. EFS works by providing a network file system volume. NFS is a nearly 40-year-old standard. All Linux distributions support it, so we don't need to rewrite the application. All we have to do is mount the NFS share on the instances as a normal file system, and we're good to go. Using S3, on the other hand, would require installing some third-party tool on your instances to allow them to mount an S3 bucket as a file system. It's not very clean, and it is likely to break. So EFS is our best option here. Okay, as it stands right now, we're looking at 99.97% availability. But we have one more thing to consider, the database. For that, we're going to use Amazon's Relational Database Service, or RDS. RDS gives you managed versions of MySQL, MariaDB, PostgreSQL, Microsoft SQL Server, and Oracle. And the nice thing about it is that AWS handles the database management system and the underlying infrastructure. They are responsible for taking backups and ensuring that the database infrastructure meets a certain level of availability. Now, the first question that should pop into your mind is, what's the availability of RDS? Well, RDS offers an option called Multi-Availability Zone, or Multi-AZ, which gives you 2 database servers in different zones. If you run Multi-AZ, you get a guaranteed availability of 99.95%. The database is a hard dependency, so we need to multiply this number, 99.95%, by the number we came up with a moment ago, 99.97%, and we get 99.92%, which is almost exactly 7 hours of downtime per year. That is right on target. We need our application to be available 99.9% of the time, and we're beating that with an availability of 99.92%.